This is a video on using features of the normal distribution to make decisions. Before we get started on our warm-up on page 29, I just want to draw your attention to one of the homework questions that I'm guessing a lot of you were a little concerned about. It's this last one from last night on page 28. The answers in the answer key were not really correct. Like for letter A, see how the curve kind of stops here at 270? It goes from 230 to 270, and we know that that happens in 3 standard deviations. So it would be like, so the difference between 230 and 270 is 40, and 240 would equal 3 standard deviations. So really it's going to be more like 13 and change. So just wanted to point that out. The answers here were wrong. Like this should really be like about 13 and change. This should be about 26. This should be about 40. Okay, so let's return our attention to page 29. Please pause the video and work on the warm-up. Okay, at this point you should have paused the video and tried these problems. And I'm being asked to rank the data, largest standard deviation to smallest. So when I look at these 4 sets of data, I immediately notice that these ones are all the same. So I know that this will be the smallest. Okay. So now I look at the others and I see that probably D is going to be the next smallest because these are, spaced apart just by small amounts. And I see that letter C, they're spaced out by, like 1 each. But then when I look at letter A, I see letter A has an outlier here. It's got an outlier here at 2. And so even though these are only spaced apart by 1, the fact that this is 2 is going to make the standard deviation much larger. So A will have the highest standard deviation, then C, then D, then B. Remember, B's standard deviation is 0 because they are all the same. Just as a reminder, if you were using your calculators, which you were not to be doing, the average is going to be the same as X bar on your calculator, but population standard deviation, which you can see on your calculator as this symbol little x, will not equal sample standard deviation, so just be aware. Number 2, for a problem, the mean is changed from 1 to 5. How does this affect the normal curve? Well, all that happens is that the entire curve moves to the right. For a problem, the standard deviation is changed from 5 to 1. How does this affect the curve? So 2 things happen. First off, the curve is more compressed. You can say it's more narrow, that's fine. And the peak is higher. I am spelling. And it's higher because more data is clustered at the mean. Okay, so today's lesson is going to ask us to look at some normal situations and use the fact that these situations are approximately normal to make some decisions. So if you would kindly pause the video and read all of page 31, just read over it. Okay, so what we see here is that we've got a normal distribution with the ACT. The ACT is normally distributed with a mean of 21 and a standard deviation of 5.2. So we are not going to worry about using technology. We are just going to use this information to sketch a normal distribution curve. I've got 1 shot, so I hope I do a good job. Well, that's not so bad. Okay, so here's my mean. The mean is at 21. And my standard deviation is 5.2. So I'm going to add 5.2. So let's see. This looks like the inflection point. So I'm just going to put my lines in first. So that's 1. I'm going to try to keep this symmetrical. It's not perfect. And then this is going to be 2, 3. 2, 3. So here we go. 21 plus 5.2 plus 5.2 0.4 plus 5. Now this is where you have to kind of know that, like, I'm gonna write this down, but really I know that the ACT only goes up to 36, but that's okay. I'm still gonna write 36.6. Now I'm gonna subtract, so this is gonna be 15.8. Yeah, and then this is gonna be 10.6. This is gonna be 5.4. Okay, so that's pretty good. This looks a little wide, but that's okay. So I have sketched my normal curve for this test. Now number 3 says, in what is normal, you learned this empirical rule. Use the rule to answer. Well, before I use the rule, I'm gonna actually label my picture. So from here to here, I have 68%. That means I have 34 and 34. Then between 2 standard deviations, so from here to here, I have 95. So now if I do 95 minus 68, I would get, I would get 27? 27. And if I divide the 27 in half, that means in this section, they have to add up to 27. They're each going to be 13.5%. So then that's between 2. So now if I go 3 standard deviations out, I'm going to do this really lightly. Well, I don't know. Here, here. That's our 99.7. So if I did 99.7 minus 95, I get 4.7, and that means that right here I have divide that in half. I have 2.35%. I have 2.35%. And if plus and minus 3 standard deviations is 99.7, that means that in these little pieces I have 0.15 because it's that 0.3 divided by 2. Okay. Here we go. What percentage of students scored below a 21? Well, that's pretty easy, 50%. It's right in the middle at the median. What percentage, so we've got to be careful, about what percentage of students scored below 16? So because it's about, I'm going to use this 15.8 line. And there are a couple of different ways to do the arithmetic. The fastest to me is I know that each half, the left and the right half of the curve is 50%. And if I do 50% minus this 36%, I've got 16%. About what percentage of students scored below or between an 11 and a 26? So I'm going to use the 10.6 and this 26, and I'm going to add up these 3 percentages. So let's see, I get 68 plus 13.5 would be about 80, 70, no, I was right the first time, 81.5. About, it's an about. Okay, so I'm gonna leave the graph up, and what I want you to do is turn the page and read number 4 along with me. It says, your friend Calvin would like to go to a very selective college that only admits the top 1% of all student applicants. Calvin has very good grades and scored a 33 on the test. Do you think Calvin's ACT score gives him a good chance of being admitted? So if they're only going to take the top 1%, well, we know right now, first of all, that this 36 is like really not possible because it has to be 36 even. So let's think. If I was halfway in the middle here, and be aware that there's more data on this side than there is over here, that would be like, let's think, if I add those together, 7, 8, like a 34. A 34 is right here, okay? So I'm gonna go with probably not, to be in the top 1%. And I recognize this might be a little bit over because there's more data here than there is here. I'm gonna say, does he have a good chance I don't know. I would say no. I would say he only has an okay chance. And again, this is an opinion question. There's no perfect answer. I'm not going to write all that out. He probably needs a higher score, really, to have a good chance. All right, so what I want you to do is I want you to pause the video, read number 5, and create a normal curve like we did on the previous page. All right, at this point you should have paused the video and you have created this curve. You've made a nice smooth curve. In the middle you put 120 because that's 2 minutes. And then 1, 2, 3, 1, 2. Mine are never even. I don't know why. 13, so this is going to be 133, 146, 159, and this is going to be 107. This is going to be 94. This is going to be 81. Okay. How much time would you recommend for microwaving the popcorn? So I want to point out, over here, if you leave the popcorn in for like 3 minutes, over here, it gets burnt. If you leave it in too long, it gets burnt. If you don't leave it in long enough, it's unpopped. So the question is, would you rather have more unpopped or would you rather have more burnt? And again, this is a little bit of an opinion answer. Like I would probably go personally, I'm gonna go slightly under 2 minutes. I might go with the 107 because I don't like burnt popcorn. It's gross. Burnt popcorn is gross. Okay. In case you haven't noticed, the theme today is create a normal distribution curve. So go ahead and turn to page 33. I want you to read the scenario and in the white space on the right, create a normal distribution curve. Obviously, pause the video. That one's lopsided. All right, so 6, 7 plus 4 inches is like 6, 11 plus 4 inches is 7, 3, and then over here we've got 7, 7. And now subtract 4 inches, I've got 6 feet, 3, 5, 11, oops, and 5, 7. 7? Yeah. No, yeah. Okay. So here we go, and I'm going to put my 33, or 34, 34. This is 13.5%. This is 2.35. This is 0.15. 13.5. 2.35. 0.15. Okay. What percent of players are taller than Greg? Well, Greg is 6'3". Here is Greg. Taller than Greg. So who is taller than Greg? Everybody on this side is taller than Greg. So what I'm going to do is I know half the picture is 50%. And so 50 plus 36 is going to give me 84% are taller than Greg. What percent are shorter than Greg? So go the other direction. So either you can think about it like, okay, this is 84%, the whole picture is 100, 100 minus 84 is 16%, or you could add up all these guys over here who are shorter than Greg. How tall would Greg have to be in the top 2.5% of player height? So right here, this number, because if I add up 2.35 plus 0.15, that would be 2.5%. So Greg would have to be 7 feet 3 inches. All right, so pause the video and think about number 2. All right, so number 2, again, curve time. Oh, that is so ugly. That's okay. 5, 6, plus 2, 5. Oh, these guys are short. I would fit in well in this school. 5, 10. Man, my picture is ugly. And then 6 feet. And then take off 2, 5, 4. 5, 2, 5. Okay, what percent of students is Greg taller than? Well, Greg is really tall. Apparently people at this school are pretty short. Greg is 6'3". Greg is an extreme outlier. So Greg is taller than basically everyone. Like pretty much everyone. Here's a better question. What percent are between 5 and 5'8"? So here's 5. Here's 5'8". I want to add up this portion. So I know that this is 34, 34, 13.5, and 2.35. So that's going to be, I want to say it's 83.85. You should check that on your calculator because I just did that in my head. It seems right though. Yeah. Cool. All right. Jordan is drinking a cup of hot chocolate. From previous research, he knows it will take a cup of hot chocolate 10 minutes to reach a temperature where his tongue will not burn. The time it takes the chocolate to cool varies normally with a standard deviation of 2 minutes. Okay, if he wants to, so again, at this point you should know, we're drawing a normal curve. So pause, draw the curve. Well, that's so ugly. 10. Minutes, 14 minutes, 6. Okay, well, it's 16 minutes. It's cold. Hot. Like if you wait too long, the hot chocolate. I like to do this because otherwise I struggle in answering these kinds of questions. Like if you wait, like I don't know which side to pick. I'll show you what I mean. Just like with the popcorn, I really like to write unpopped and burnt because then I know what I just have a better idea of what I'm trying to do. That was as clear as mud. All right, so like if I only wait for 4 minutes, I'm gonna burn myself. If I wanna be 84% sure, well, I know that this half is 50, and I know that this is 34, so 84 is gonna be 12 minutes. I mean, think about it. If you wait for 16 minutes, you are definitely not gonna burn yourself because your hot chocolate is gonna be like chocolate milk. But if I wait 8 minutes, okay, so here's 8 minutes. What percent of the time will I burn my tongue? So here's my question. This is hot, but this is the probability that I'm sure. Not sure, but you don't burn. Now, on this side, this is the probability that I will burn my tongue because, oh my God, I can't spell. Because think about it, like if I wait for 16 minutes, the probability that I do not burn my tongue is very large. The probability that I burn my tongue is going to be very small. It's just going to be this little tiny piece. So if I waited 12 minutes, again, this is the probability, it starts off hot, it gets cold. This is the probability that I'm not burning my tongue. Not the probability that it's hot. It's the probability that I'm not going to burn my tongue. This is the probability I will burn my tongue. So as I wait longer, the will burn side gets smaller, the don't burn gets bigger. So if I wait 8 minutes, what percent of the time will I burn my tongue? it's going to be on this side, so it's the other side. 84% will burn. So like for example, right here at the average, it's 50%, you're still, like this is like the chance you're taking. It's 50%, it won't burn. 50%, it will burn. Okay, like think about it. If I wait only 4 minutes, 4 minutes, I have a very small probability that I won't burn my tongue, and a very large probability that I will burn my tongue. All right, your homework tonight is pages 34. Actually, I think it's just page 34. Is that awesome or what? Yes, it is just page 34. So go ahead and you can use the back of this paper. You got lots of space.